Hello everyone, this is Navneet Saxena from Narayana Delhi Mayur Vihar Center, and today we are going to discuss NEET 2021 paper. So let's start with the discussion. Okay, so in this paper, the first question, there are overall 50 questions and we are going to discuss them part by part. So in the first question, a cup of coffee cools from 90 degrees centigrade to 80 degrees centigrade in T minutes. When the room temperature is 20 degrees centigrade, the time taken by a similar cup of coffee to cool from 80 to 60 degrees centigrade in a room temperature same at 20 degrees centigrade is. So what you need to tell is what is the time required to cool it from 80 degrees centigrade to 20 degrees centigrade. So what is required over here is Newton's law of cooling. What is required over here is Newton's law of cooling, which is basically delta theta by delta T is equals to some constant C and theta average minus theta naught, which is the surrounding temperature or the room temperature in this case. All right. So let us put this formula for the first case, which means it is cooling from 90 degrees centigrade to 80 degrees centigrade, which means the temperature difference delta theta is 10 degrees centigrade divided by time T. All right. And the average temperature is, see, 90 and 80 make an average temperature of 85, that is quite obvious, minus the room temperature, that is 20 degrees centigrades. Okay, so this is our first equation. All right, now let us take the next case. You have to find the time taken for the similar cup of coffee to cool from 80 to 60 degrees centigrade, which makes the temperature difference 20 degrees centigrade. And let's take time that T dash. Okay, let's take that time as T dash. So what is the average temperature down here? See, 80 and 60 makes an average of 70 degrees centigrade minus the surrounding temperature remains the same, which means 20 degrees centigrade. All right. So now let us divide equation number 1 and 2. So we will get T dash divided by 2T on the left hand side and 65 divided by 50 on the right hand side. So from here we definitely get T dash is equal to 13T by 5 basically. Okay, divide this by 5, we get this. So this is 13 by 5 T. Okay, so this is your answer. So 13 by 5 T, the correct option is the first option. All right, now let's come to the second question. Polar molecules are the molecules. Okay, so polar molecules are the molecules which have a permanent electric dipole moment. See, let's take an example of polar dipole moment. See, let's take HCl. Chlorine has more electronegativity than hydrogen. So the electron paired shared between these two is actually shifted towards the chlorine, which enables chlorine to create a minus delta sign and creates a positive delta sign on the hydrogen atom. So this is basically two charges of equal magnitude and opposite sign separated by the distance equal to bond length. So this creates a dipole. This creates a dipole. All right. So the third option is the correct option in this case. So polar molecules are the molecules that have a permanent electric dipole moment. All right. Now let's come to the third question. So there's a nuclei of mass 240 that breaks into two fragments, each of mass 120. So let's write this equation X. Let's take the parent nuclei as X and it creates 120 mass number 2 nuclei. Okay, let's take that Y. The binding energy per nucleon of the unfragmented nuclei is 7.6 million electron volt. So the EBN value, which is binding energy per nucleon value, is given as 7.6 million electron volts. And the fragment that is formed, which is Y, has a binding energy per nucleon equal to 8.5 million electron volts, right? So from this expression we can definitely see that the binding energy per nucleon of the product is greater than the binding energy per nucleon of the reactant, which makes the product more stable than the nuclei of the reactant, which makes this process spontaneous. All right. Now, let us calculate the binding energy of this nuclei. See, 240 is the mass number and 7.6 is the binding energy per nucleon. So obviously we can say the binding energy is 240 multiplied by 7.6 million electron volts, and the binding energy of this is 2 times 120 times 8.5 million electron volts. Now if you calculate this value, this will come out to be 1824 million electron volt, and if you calculate this value, this comes out to be 2040 million electron volts. Now if you take the difference of this will come out to be 216 million electron volts, which means that the correct option is the third option. All right, it means the third option is the correct option. All right, now let's take the fourth question. An electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. All right, so the work function is negligible, which means that all the energy of the photon is converted into the kinetic energy of the electron. Okay, and the mass of the photoelectron emitted from the surface has de Broglie wavelength of lambda d. Then you have to find the relation between lambda d and lambda. So basically, energy of photon is equal to kinetic energy of electron minus work function, which is basically 0. So you can write this is equal to kinetic energy of electron. Okay, so now we can say hc by lambda is the kinetic is the energy of photon, and this is equal to, we can write this as p square by 2 into mass of electron, which is m. All right, now what is the de Broglie wavelength associated with this electron? So lambda d is the de Broglie wavelength, and that is equal to h by p. So from here we can figure out that p is equals to h by lambda d. So here we get two equations. See, this is the first equation and this is the second equation. Now we need to solve these two equations, and for solving this, what we need to do, instead of p, we should write h by lambda d in this equation, and solving this we will get lambda is equals to 2 mc lambda d square divided by h, and this is our answer. All right, so from here we can conclude that second option is the correct option. All right, now let's come to the fifth question. It is saying a radioactive nuclei XZA undergoes spontaneous decay in the sequence ZXA gives Z-1b, gives Z-3c, gives Z-2d, where Z is the atomic number of the element. Okay, the possible decay particles in the sequence are, so in the process X to B, which makes the atomic number decrease by 1, it is definitely a beta positive particle, which means a positron is being emitted from the nuclei. That gives us beta plus decay. Now let's take B to C, which basically means the atomic number is decreased by 2. Sorry, this is Z-3. All right, so decrease in 2 means a production of the alpha particle, which makes the mass number decrease by 4 and the atomic number decrease by 2, thereby releasing a helium nuclei from the atom. So this clearly states that the second particle emitted is alpha particle. Now let's take the D atom, which has an atomic number of Z-2. So the atomic number has increased by 1, which means the decay is definitely a beta minus decay, thereby creating an electron from the atom, because of conversion of a neutron to a proton, thereby increasing the atomic number by 1. So the sequence, the correct sequence is beta plus, alpha particle, and beta minus particle. So the correct option is the second option, and that is the correct option. So let's come to the sixth question. Column 1 gives the certain physical quantities associated with flow of current through a metallic conductor. Column 2 gives some mathematical relations involving electrical quantities. Match column 1 against column 2 with appropriate relations. So this is a fairly simple question. The value of drift velocity is well known and it's given in the NCERT as EE by m times tau. Okay, the electrical resistivity is obviously E by J, because we know this formula as J is equals to sigma times E, and sigma is 1 by rho times E. So the value of rho is E by J. That is the resistivity. All right. Now the relaxation period, which is known as tau, is given by this relation, and the current density is NEVD, because it is I by A, area. So the correct relation is A to R, B to S, C to P, and D to Q, which makes the fourth option as the correct option. All right. Let's come to the next seventh question. In a potentiometer circuit, a cell of EMF 1.5 volt gives balance point as 36 centimeter length of wire. If another cell of EMF 2.5 volt replaces the first cell, then at what length of the wire the balance point occurs? So we know about the potentiometer circuit. We know that in a potentiometer circuit, the balance point is basically obtained according to the length of the potentiometer wire. And we know that the proportionality exists over here, that E1 by L1 is equal to E2 by L2. All right. So in the first case, it is 1.5 and the length is 36, which means 36 centimeters. Let's write this in centimeters. Okay. All right. And in the second case, the EMF is 2.5 and we have to find the value of length. So you just need to calculate this value. And upon calculation, this comes out to be 60 centimeters. Since the starting unit was centimeter, so the answer will also be in centimeter. The correct option is the fourth option. Let's come to the next question. The velocity of a small ball of mass m and density d, when dropped in a container filled with glycerine, becomes constant after some time, which means that the ball has acquired terminal velocity. If the density of glycerine is d by 2, then the viscous force acting on the ball will be. So let's take a ball and let's apply the forces. See, this is the mg force acting on the ball. And obviously, if it is in a fluid, there will be certain amount of buoyancy acting on it. We have written this force by B. And now let us write the viscous force, since this ball is moving downwards, because the density of the glycerine is less than the density of the ball. So this ball will be moving downwards, so the viscous force will be acting upwards. And in equilibrium, obviously this is an equilibrium because it has attained a constant velocity. We can write Fv plus B is equals to mg. All right. Now let's take this as capital M, because it is given as capital M in the original question. Now the value of viscous force is equals to mg minus b, and from Archimedes principle we can say that this value is equals to velocity, volume times density of fluid times g. All right. So this value becomes, volume means mass divided by density of the solid body times density of the fluid times g. So this becomes mg minus m. Density of solid is d and density of fluid is d by 2. So this comes out to be mg by 2. So the viscous force acting on the body becomes mg by 2. So fourth option is the correct option. All right, let's come to the next question, ninth question. A lens of large focal length and large aperture is best suited as an objective of an astronomical telescope since, see, large objective implies that a large amount of light energy or a large intensity is coming inside the telescope, which makes the image quality better and increases the brightness of the image, which makes the first option and the second option correct. It has a high light gathering power and it makes the visibility of the image better and the quality of the image better. In addition to that, we also know that the resolution of the telescope depends on the diameter of the aperture, which makes the resolution also better. So all these options are correct, which basically means what we have to take, we have to take the fourth option, that is all of the above. All right, let's come to the next question. Two charged spherical conductors of radius r1 and r2 are conducted by a wire, which means connected by a wire, right? Then the ratio of the surface charge densities on the spheres sigma 1 by sigma 2 is, see, let us take the two spheres of radius r1 and r2. Let's say this radius is r1 and let's say this radius is r2 for our convenience. Okay, and since they are connected by a wire, we can say that let's say this charge is q1 on this and the charge is q2 on this, and since they are connected by a wire, we can say potential of each of these sphere is same, and let's take that potential as V. So what we can write is k q1 by r1, which is the potential of the first sphere, is equals to k q2 by r2, which is the potential of the second sphere. And now what we can write, we can divide and multiply this by r1 and r1, divide this by r2 and r2, and we can divide this by 4 pi and 4 pi. Okay, so from here we can say r1 times k times sigma 1, which is q1 by 4 pi r1 square. And from here we can say r2 times k times sigma 2. All right, from here k and k gets cancelled and we have to find the relation between sigma 1 and sigma 2. This comes out to be sigma 1 by sigma 2 is equals to r2 by r1. This is our final relationship, and with that we can say that the first option is the correct option. All right,